So now I'm going to elaborate the lesson SDLC, right? Fine. Before learning this SDLC, right, you have to learn about systems. Okay. System is simply, I'll show you. System is simply having input from the surrounding, right? And then you have something inside, and then you put output to the surround, right? So the system has surrounding and it has a boundary and the system is inside of it. So the definition for the system is collection of interrelated components that work together in order to perform a specific task. For example, take your respiratory system, right? You inhale, okay, you take oxygen, then it goes through your trachea to your lungs, and then, okay, through alveoli, it will do some processes, and then you will exhale carbon dioxide, right? So it's a system, okay? That means you take things from surrounding and you have a boundary, okay? Inside that, your system works, and then you give some output. So the what you call the task or the objective of this respiratory system is to take oxygen and other things and then exhale carbon dioxide, right? That is the purpose. So it's like it has several components to work. You have trachea, you have lungs, you have alveoli, and you have nose, and other, there are lots, right, in the respiratory system. And also think about your we'll take digestive system, okay? So you have your intestines, your bladders and your tummy and your esophagus and everything. They are the components that they work together in order to digest your food, okay? So they take in things input from your mouth, right? So likewise, okay, and then the nutrients will be gone through the your blood and all, okay, to your vessels. So that is also another example for a system. So that means system, so you can understand it's collection of interrelated components, okay, that work together in order to perform a task. So these systems are there in the computing world also, okay, because computers, everything is made of, all these things that we see and that we take to do our day-to-day things are systems, right? Because they only can't work with one component. They have several components like that human, for example, natural systems. So man-made systems also have several components that work together in order to perform this task, perform any task, okay, that is given to them or that is pre-designed for them, right? So system has inputs, some components, and then it do some processes, okay, comparisons or calculations or anything, and then it gives you the output to the surrounding back again, right? That is a system. So there are types of systems: open system, closed system, natural system, man-made systems, and all, right? Open systems means that it's open. For example, now your respiratory system is an open system, where you have your mouth and nose that are open to the surrounding, right? So it's an open system. Closed system, your blood circulatory system is an example for closed system. Why? All the things will go inside your system, inside your body. Without a wound, unless wound, you won't take blood out. Anyway, it goes inside, right? So it's a closed system. The interrelated components will work inside the system without, the connection with the surrounding, right? So they are the closed systems. Open systems, they have anyway the connection between the outer environment, like you breathe from your nose and you can exhale from your mouth, okay? So like that. So in computing also we have to consider this, because when we are developing a program, system means actually like a program, okay? So we have to know about the surrounding. For example, if you are making for a company, you have to know about the stakeholders. They are the surrounding, the background, okay? The customers, who are dealing with the company, the suppliers, the distributors, the employees of the company. And when you are making the system, you have to think about what you should do, or what are their objectives and what they want to do from your system. and what you're going to give them output. For example, think they are want for a, okay, we'll take an example. I'll do this example with a hospital system, right? So you're asked to make a system for the hospital. So you have to take all the details from the surrounding, right? Okay, what the, you can go on them. And now I'm going to start on discussing this SDLC with that, right? So this is this SDL, system development life cycle, right? This means the software development life cycle is same because system is actually a software that we are designing in the computing world, right? So now I told you we have a surrounding and we have a system, right? So usually these computer systems are open systems. Why? The what we do inside, we have to give it to outside and take things from inside in order to upgrade the system and do the things, right? So when you take the things, for example, I told you, okay, we'll think about the hospital system, right? So think in a hospital like ABC Hospital ask you, your company to develop, you are a software company, to develop a software for them. Okay, so they want to have their patients details, the doctors details, their laboratories and their operation, like their theater works, and about their human resource, I mean their employee works and all. And they want to keep their records, right, their medical records of the patients, okay, and so, right? So as business analysis and program designers, okay, BA, that is a one of a occupation in the software industry, right? They goes to the companies, okay, for example, we'll think that now they are taking hospital management system, right? So they go to the hospital, they meet people there, like the higher managements and all, middle management and lower management and everyone, and even the normal, like, you know, those minor staff, and they have to collect data. They have to identify the requirements of the company, right? Okay, what they want. Okay, now I told you they want to keep their patients' details, their records, okay, and they want to send SMS to them when they have any promotions. Likewise, they want to collect data what the company wants, right? So they're going to meet those stakeholders and other employees and all, and they collect data. That is called this analysis, requirement gathering, and then we have to analyze it, right? So they do this requirement gathering with several methods through interviews, right? They can interview the management and all. Anyway, the patients, even the patients, sometimes the patient may say, "I think you are having a manual system. The hospital has a manual system. Now they want to upgrade it to a computerized system. That's why your company is given the chance to do it, right? I mean, the opportunity to do it. So even you can go to patient and ask, okay, do you think this is good? Like you can interview. Then he can say, yes, it's good to have a computerized system so we can pay our bills online. Otherwise, we have to come. It's good to do e-channeling. Otherwise, we have to come to the hospital to pay it, and so and so. So you can collect, okay, that person says he wants e-channeling facility. So you can jot it down. Likewise, you can have interviews. You can have questionnaires. That means you can print a questionnaire with like related questions, set up pre-defined questions, okay, and then you can distribute and collect like a survey. You can collect the details, and you can see the sample documents of the hospital, the previous documents that it has. Okay, okay, how they want, like for example, they want to keep up the give the invoice. I think you are staying in the hospital for 2-3 days. So how the bill is, how they are doing the bill out. Now I told you they are doing the manual. They are doing it manually. So how they are, what are the fields they are having? Okay, they are having the patients, what you call, the unique number, primary key for that, and the patient's details and his addresses. What are the fields that they keep the records of the patient? So you can have those sample documents when we are creating it using a database, right? And then also you can make a prototype. Okay, that means you can design a sample like a model, right? That's a model, and then you can show it to the company and then ask, okay, then they will say, okay, you want to do something more to that. This part is good. You can take the feedback. So with them, you can collect data and you can do the requirement analysis best. Okay, so through interviews, through questionnaires, using sample documents, and through prototype, okay, you can collect data from the company and its surrounding, the surrounding, right? Then Once the business analysts and project designers, like those people, managers, they come up with this data, then they design. In this designing phase, they design, okay, they want an app. They just, they just plan what they are going to do. Okay, they want an app as well as they want a website. Okay, so they want to keep databases on these area. They want to keep database on the doctors, or for the doctors. They want to keep database about patients. They want to keep their history, okay, about each patient's records or their tests. Like now, the hospitals have various types of tests, right? What do you call that? Adults for them, okay, and health checkups, okay, female health checkup, like they have different types. So likewise, they want to keep up the records, right? And the online payments, how to do them, okay, what they prefer to do them, their colors they want for their, like for example, some like the companies, they have their theme colors. So what colors you have to use, okay, what fonts you have to use, like you design it, right? So this is a big process that you design, you take time and design, okay, what are the links you want, okay, how many pages of the website you want, okay, so to whom you are going to give the authority. And also you have to check whether your company is feasible on that, right? Whether you can take, you have the needed technology, you can do you have the human resource, I mean capability to do the things, and so and so. That is designing part. Then the implementation part, or the coding part. So here the software developers, and so the design is done usually by the system designers and architects and all. Then here the coding people, system developers, okay, they are implementing the code. So they use a programming language according to the guidelines given by the system consultants in the company or the architectures. They are coding, right? They are coding, say that now Pascal. So there are lots of languages there they use. So they use this Java. Java is like, it's like the most used language nowadays. So they define, now in the design they have classes and all. So what are the things you have to put up for the classes, what are the inheritance on that, okay. Likewise they will do the thing. Then they will move to testing part, right? Testing people are there to test and debug. So they will find bugs when you implement a program. You are now checking it or testing it against the user requirements, whether they are, then you can check whether your program is correct, right? It won't be almost correct, that's why you want to check. So you will find bugs. Bugs simply means the errors, right? So when you find the errors, okay, then you can debug them. That means remove errors. So testing there are several testings. Your level, you have unit testing, there are major levels, right? They are the major ones. Unit testing, integration testing, system testing, and acceptance testing. So unit testing means simply you are checking individual components. Okay, for example, the online part, I mean the online payment part of the company, I mean of the hospital, and then the human resource part. Likewise, each unit. Then you are integrating several units. Like for example, now the online payment unit has to have the connection with the management, right? Because because they want to take the reports of their accounts, how people are paying it. They want to check if they want to get the final what all their profit. Okay, so they have to have connection. So those separate units we integrate and check whether the connection is good, okay, whether the databases are working, and so and so. Then the system testing. So altogether, all the components, all the separate units integrated are tested together in the system testing, right? These three levels are done at the company where they are producing the software. And this is given to the user as an acceptance testing. So the user will check whether his requirements are met in the program. Okay, whether, okay, this field is not there. So they can give their feedback, their comments, right? So they are the 4 steps in testing, right? Unit testing, yeah, several units are, each unit is tested, the integrated where several units are connected and tested. System testing where as a system is tested. And then they connect it as, make it as system and test. Then they gives to the then they use the acceptance testing, that is used by the end user, right, in test. And then after they have, like, there might be bugs anyway, right? Anyway, they can sort out lots of bugs in there in the testing phase. Then they are giving it to the deployment. Okay, deployment means simply install and use. The meaning of the word deployment is install and use, right? So that means you are going to give it to the company. Okay, so here now I told you this ABC company has had a manual system. Now they want to replace it with this computerized system. So there are like deployment. There are 4 types of deployment: direct deployment, parallel deployment, pilot deployment, and phase deployment. Okay, so here direct deployment means now the ABC hospital has their manual system. I'm replacing it totally with my computerized system. That means I ask them to take off all their manual things and install my software into them, deploy my software and use. That is the direct deployment. There are both pros and cons in each of these. Okay, and this will once this will be good because you are removing the all things and good, but there is a disadvantage. But since think you will lose data. Okay, your manual systems may have data more than your computerized system, so you will lose. So there are pros and cons. Anyway, that is direct deployment. Okay, anyway, you have to train the company people in order to how to use the program or not. So they are also done by the company. So that is direct deployment. Then parallel deployment means I'm telling to the hospital higher management that you can keep your manual system, and while with that I'm introducing my computerized system. So I can train the employees of the hospital, and while on that you can do the manual system and the computerized system parallelly. You understand? Like it goes like a track, like both. So they can adapt to the system as well. So anyway, there are also some cons because you have to have 2 staffs in order to train and all. So there are disadvantages. And then next one is pilot. Pilot deployment. That means you are now think your ABC of this hospital has some branches in several places. So you are going to give this software into few branches, not all the branches, and then check whether they are working at that branches. For example, think you are having branches in Colombo, Kandy, Kurunagala, and Radhapura, but you are only giving these to Kandy and Kurunagala, not then the other 2 will work with the manual system, and then you are checking with that 2 whether they are good, and if they have errors, they can give the feedbacks, and they can like anyway the software company is dealing, I mean having the connection with the ABC company through that. So they are giving it to some branches, okay, and then they are checking whether it's working, and then they can give to all its branches, right? So pilot is like like a like a test they are like giving, right? And then the phase deployment. You are giving your program phase. I mean, phase, that means several units, right? You are just first giving them the patient's part of your program. And then the doctor's records things, likewise, phases. So with that 4 deployments, you can install, you can install your software into company and let them use it. And also, as a software company, you have to maintain the software because they will find errors. They will have new requirements. Now, think the company would need something like, the hospital would need something like foreign interaction with their hospital. That means they want to take foreign testing things, laboratory things in order to manipulate in Sri Lanka. So in that case, they have new requirements, right? So the companies, while they keep on maintaining, so they will gather the things as well, and this circle will iterate, right? And then one after the other, there are several models, waterfall, rapid application development, agile, and Scrum. There are lots of things. So with that, the companies will inherit to that models, and then they will keep it on maintaining the software while having the connection with the company. So that's how this software development life cycle happens, like the life cycle of a frog you think, right? So step by step things will happen. In each step, there is a way. So you have to remember this. So at the last, I want to say you have to remember, okay, how you can gather information, that analysis. So what is happening in the implementation? Okay, it's coding. Then what are the 4 testings? Okay, each testing you have to remember. Then they will ask you about the deployments, the 4 deployments, and so and so. And also the question will come like this for your O-level exam. They will give you a scenario, for example, like the ABC hospital that I told you. And then they will ask, what is the best deployment for this? Then you have to verify your answer. Think you are using this parallel deployment. Then you have to verify why you think this is good. Okay, likewise. So likewise, you have to clarify. You have to give the why you say it's true, it's good or bad, right? It might be bad, might be good. So you have to anyway give your comments on that. And they will ask you, now the company will use what you called questionnaire gathering. I mean, questionnaire requirement analysis. So why do you think questionnaire is better than interviews? Likewise, they will ask. At that point, you have to think of it. Okay, elaborate. You just imagine that you are in the situation, that you are the business analyst at that point, and then you just think and write the answer. Don't just write like one or two sentences. Just you try. Don't write like paragraphs, but you just try to simply give your words with technical terms on your page. Okay, for example, this requirement gathering, like don't tell like collect data. Okay, that's like a primary word. Like, so use some technical words. Okay, and then write your answers neatly. Then you will score good marks. There might be a question from this lesson. Okay, so I hope you all understood about software development life cycle. So this is the second lesson of grade 11 book, and this is useful for your O levels as well as for your A levels, right? This lesson will continue to there, right? Then you have to learn about the waterfall model and the iterative model. Simply, waterfall model means these are the models, right? So this is the normal phenomena, like how it happens, and there are some models that companies will do, I mean, will take over in order to give the final output to the customer. So there are several models. Waterfall is one of it, where each step is happen after the previous one is completed. For example, after you gathered all the requirements, then you move to design. That means while you are gathering requirements, you can't move to design. You have to finish one phase in order to move to next, like the waterfall, how the water flows from up to down, right? You won't take water from middle and put it again up, right? Water will flows from top to down, right? Likewise. So there are pros and cons in this one as well. For example, if you have like a small project, you can implement waterfall without any doubts, and which has its requirements stable. Okay, if the company has changing requirements, you can't adapt it with, you can't make it using this waterfall model, because when think you are in the implementation level, the company will say, okay, I want this, so how to do? You can't go reverse, like you have to complete it and then start it again. So it's like a waste of time and your energy, right? So for that, if the requirements are changing constantly and the project is so complex, likewise you can use this iterative implementation model, where like small parts of each of these software development lifecycle is taken and it's iterated. For example, requirement analysis is done, while on that the designing is done, not the whole project, parts by parts. Okay, and then implemented, you just code a little and then you test a little, then you install it, and then you keep on. Again the customers will tell something, again you iterate, like you repeat the circle. Likewise, that is the iterative model. So there are, according to the question, you have to like contrast these two words, compare and contrast, and these models, we have to write the answer. If they say the company has their requirements changing constantly, so what is the best model? There you must write iterative model, not the waterfall model. Okay, but they say this is a simple project, then they have stable their requirements, then you can write this waterfall model. So likewise, the question will come for your exam. So I hope you can write your answers best for this question.